Solving right triangles with trig, part 1, finding a missing side. This lesson will cover finding a side that's missing on a right triangle when we have an angle and another side. Here are the calculator notes, or just a few hints that help us when we're using trig, because we are going to have to use the calculator. There are sine, cosine, and tangent buttons that we'll use that will be very helpful to us throughout our study of trigonometry. You can use your calculator to evaluate the expressions involving trig ratios. Now, as we're working with our calculator, many of us have not checked the mode, and that's one thing we'll have to do. So I'll go ahead and show you how to do that with your calculator. With your calculator on, hit the mode button. It's right next to second. Scroll down to where it says degree, which is right here. Hit enter and make sure that you have it highlighted like it is now. I also have this set to float of 4 because that means it's going to give me 4 decimal places. Once you're done with that, you can hit second, quit, or second mode, and it takes you back to your home screen. Now, example 1 says find the cosine of 41 degrees. What we're going to do is we're going to hit the cosine button, plug in 41, and that'll give us our decimal value, our ratio in a decimal form. That's 0.7547. Part B of this example is to define the sine, so I'm going to use the sine button, of 78 degrees. That's 0.9781. So we did that on the calculator, and we found that the cosine of 41 is 0.7547, and our sine of 78 is 0.9781. So let's look at our first example. It says find the missing measurements. What we're looking for here is what is the value of x. We want to know what's the length of x if this side is 9 and we have an angle that's 21 degrees and an angle of 69 degrees. With trig, we're able to find that out because trig is based on a ratio of side lengths of triangles. So the first thing we need to do is we need to pick what angle are we going to work with, the 21 degrees or the 69 degrees. It doesn't matter because you'll still get the same answer. So let's just start by picking the angle that's 69 degrees. I go ahead and mark my angle so I know what I'm working with, and then I label my side lengths based on that angle. Remember, the hypotenuse is always across from the 90-degree angle, and then my x value here is my adjacent because it's right next to the angle. Now, every time that I've ever done trig, especially when I was learning it as a student myself, I always wrote out a table to help me remember the trig ratios. And like I said in the last video, my teacher taught us Oscar has a heap of apples. That helps me remember what my ratios are. And the reason that's important is because that tells me which trig ratio I'm going to use. I can either use sine, cosine, or tangent. In my problem, I have an adjacent side and I have a hypotenuse side. If you notice, that's the cosine trig ratio, because cosine is adjacent over hypotenuse. So to solve this problem, I know that the cosine of 69 degrees is equal to my adjacent, which I don't know, it's x, over my hypotenuse, which is 9. I need to know what x is. That's the whole problem here. So to do that, I can multiply by 9 to cancel it out on one side, multiply by 9 on this side. So my equation is 9 times the cosine of 69. So how do I figure out what x is? I use my calculator. Make sure it's on. All I'm going to do is plug into my calculator 9 times the cosine of 69. When I do that, I get 3.2253. That is the length of that side. So my x value here, my side length, is 3.2253. Let's look at the next problem. Again, we have angles 37 and 53. It doesn't matter which we use. We'll just pick one. I'm going to go ahead and start with this angle, 53. Based on the angle, we label our sides. 13 is our hypotenuse. X is our opposite. So from our trig table that I use as reference, I can determine which trig ratio I'm going to use. You'll notice I have the hypotenuse and I have the opposite. I have O and I have H. That is my sine ratio. So to set this up, I'm going to say the sine of 53 degrees is equal to my opposite, which is x, over my hypotenuse, which is 13. Again, we're solving for x. We want x by itself. So to cancel 13 out or get 13 away from this side, I'm going to multiply by 13. It cancels here. I'm going to multiply by 13 on this side. So my equation, 13 times the sine of 53, will give me my x value. Let's look and see what that is. 13 times the sine of 53. 10.3822. So my x value is equal to 10.3822. Part C says find the missing measurements. If you notice here, we have two different measurements we're looking for. We're looking for x and we're looking for y. But we only have one angle, so we don't have to pick. We just work with what we're given. So based on that angle of 54, the x value is our hypotenuse, the y value is our opposite, and 8 is our adjacent. So let's start by finding the x value. To do that, we're just going to ignore that we have the opposite right here. So what we have is we have an h, which is our hypotenuse, and we have a, which is our angle. That is our cosine ratio. So I know that the cosine of 54 degrees is equal to my adjacent, which is 8, over my hypotenuse, which is x. There's a trick that I'll show you in just a second, but let's go ahead and work this out mathematically. We multiply by x on each side. So we have x times the cosine of 54 is equal to 8. But remember, I want x by itself, so now I must divide by the cosine of 54. So x is equal to 8 divided by the cosine of 54. That's my equation. Now here's the trick. When you have your x value on the bottom of your equation, like this. You can take your cosine of 54 and your x and switch the two. That way you get an equation that looks just like this. And you're done. You don't have to do all of this work right here. So what is that value? What is our x value? Well, we can use a calculator and plug it in. Eight divided by the cosine of 54. So our x value, our hypotenuse, would be 13.6104. So x is equal to 13.6104. Now let's find y, but I'm going to go to a new slide to do that. The y value. Again, we have our adjacent, and now we're looking for our y value, which is right here. And that's our opposite. If you remember our trig table, you'll remember that you have your opposite and your adjacent, and so then we use the tangent trig function. So the tangent of 54 degrees is equal to your opposite, which is y, over your adjacent, which is 8. To solve this one, we multiply by 8 on both sides. So our equation is 8 times the tangent of 54. Now, if we plug that in our calculator, just like we've been doing, we'll get 11.0111. Let's look at the next example on this front page. We have a triangle that have the legs is x and y. One angle is 50 and the hypotenuse is 11. Mark your angle and label each side. 11 is the hypotenuse, x is the opposite, and y is the adjacent. So let's start by finding the x value. To find the x, we have our opposite and our hypotenuse. Referring back to one of our trig tables, or our reference table, we have our opposite and hypotenuse, so that is sine. So we have the sine of 50 degrees is equal to your opposite, which is x, over your hypotenuse, which is 11. We'll multiply by 11 on each side to cancel it out. And so our equation to find x is 11 times the sine of 50. When you plug that into your calculator, you get 8.4264. Now we need to find y. That would be our adjacent and our hypotenuse. The reference table tells us that adjacent hypotenuse is cosine. So we have the cosine of 50 degrees is equal to our adjacent, which is y, over our hypotenuse, which is 11. Multiply both sides by 11. And so our equation is 11 times the cosine of 50. When you plug that into the calculator, you get 7.0706. Now, I don't want this video to be too long, so if you have any more questions, I'll help you on a individual basis in tutoring with the examples that are on the back.